Okay, we're going to talk a little bit about block prep. Now, on a Corvair, this right here is normally a cast, just a little cast V. Here we've put this on the Bridgeport, used a 3/16 end ball end mill, and opened that up. Also, we've opened up this oil hole here, the feed hole, from 170 thousandths to 250 thousandths, and also very important, we radiused this edge here, okay, because oil needs to flow just like air does, and oil is even more difficult to flow, so it's more important to do proper porting. One thing I'd like to point out, when we drill out these passages here to 1/4 inch, inevitably they break through right here, so we'll drill them out, heliarc this hole back closed, go ahead and drill them out again. On the cam bearing surfaces on a Corvair block are simply the aluminum case. So what we did here is we had this surface coated with a Teflon coating. Alright, and also you'll notice the inside of the case is all painted red. This is GE Glyptal paint. It does a couple of things. One, it'll seal in any little kind of sand or anything left over in the casting, although on a 45-year-old casing that's not really an issue. What it's doing here mostly is it's providing a surface that will allow oil to return more quickly to the sump. Also, you'll notice that we have a little radius cut here. I use what I like to call a hillbilly hone, just a little air die grinder with some sandpaper on it. And what we'll do is we will use that one just to kind of fuzz the hole a little bit, just give it a little crosshatch, and also we leave the paper out a little bit on the outside here, just to radius this edge, because if you're going to have any kind of problem, it's going to be, galling or anything. This edge here is what's most likely going to cause it. Another thing is we check the clearance on all of these lifter bores, and I'm glad I did. On a Corvair, I'm willing to run them tighter than I would on, say, like a small block Chevy. Small block Chevy, I'd want no less than 1.5 thousandths clearance. On this block, that's more towards my maximum. I'm willing to go 9/10, well, I really wouldn't want to go over 2 thousandths. This one bore right here had only 1/2 thousandths clearance, which might have been just fine. It's an aluminum block, it's air cooled, runs very, very hot, so it's going to expand a great deal. But the other thing is, though, is like if you happen to start it up when it's really cold out, it shrinks quite a bit too, and the chances of scuffing the lifter or scuffing the lifter bore are very real. So I opened that one up, so it's at about 9/10 to 1 thousandths clearance, and so now we've got, all of a sudden you see the case has been lapped. We had the case lapped. We're using ARP studs. So all these holes have been reamed. The block was torqued together in normal fashion. Then one at a time case bolts were removed, the hole reamed, and an ARP stud put in. The ARP studs are grade 8, and they install at 65 foot-pounds. The case studs, case bolts, factory case bolts are grade 5, and they install at 55 foot-pounds. So after you install the ARP studs, which each stud now acts as a dowel pin, but after you install them, it changes the main bearing bores. So we lapped the case to give it a little bit of room for our guy to line hone this, and then we had the case line honed, and it's coming in pretty close to high limit, which is just fine. One other little point is, after we lapped, right here on each hole, we gave just a very slight chamfer so that when we're driving the studs through, because they do fit rather tight, that they won't grab anything and gall and mess with the alignment at all. Okay, so now what we're going to do is we're going to torque this together, and we'll check the main bearing bores, and then we'll pull it back apart again. We'll throw the bearings in, and we'll mic up the crank, and we'll check the main bearing clearance. I set up my micrometer to the minimum size, so I know high limit is 1 thousandths over whatever my dial bore gauge reads, and I should be right about high limit on this one. And yeah, I am seeing right exactly high limit. I'll check the front. Check the back, make sure there's no taper. And I'll give a little check this way to check for roundness, although I'm not as concerned with roundness as I am concerned with the horizontal sizing. On a V8, I'd be concerned with vertical sizing. And yeah, this is absolutely beautiful. It's right on high limit. Nice and straight, no taper. These are all under half a thousandth. Like, you know, this indicator's gauged in halves. So you can't really read tenths, but I doubt there's 2/10 difference, 1 or 2/10 difference between these two. Yeah, this is just absolutely gorgeous. I've got a short indicator here, so we got to go around, flip the block around that way. Oh yeah, no, this is absolutely perfect. It just doesn't get any better than this. This one here is about a 0.5 tighter than the others, so that's pretty good. That's right on the mean, which is absolutely wonderful. Yeah, terrific. Now we'll split the case back apart, throw the bearings in, torque it back together, mic up our crank, and then we can check our clearances. I already know that they'll be beautiful because we've already done this with this case, and when I sent the crank off to be ground, because the bearings have all been coated, you can see here there's a like a Teflon coating on the bearings. That's why you see they're black. That coating is applied by hand. It's sprayed on, so the bearing shells will vary a couple of tenths. So we had already marked all these bearings, put them in, measured everything, and then gave our crank grinder instructions to grinding each main to get the exact clearance that we want. On the rods, we'll have to play around with using different size shells, extra clearance, standard clearance, and mix them around and get what we want that way. We can also, you know, hone the rod bores slightly, or cut the cap slightly, tighten them up, whatever we need there. But anyhow, now, next thing, like I said, we'll break this case apart, torque it back together with the bearings, and see where we're at then, okay? Okay, I would like to mention a little something about our main bearings. You'll notice here that we have an extra oil hole in the main bearing. I put that in, just a small 3/32 hole, and that way we still get oiling from just off the bottom, dead center top, and now a little extra oiling from the side, and put a nice little chamfer on that, you can see there. Also on the thrust bearing, we did the same thing on all of them, so all of the bearings have this extra oil hole right here. But on the thrust bearing, you notice too, on the thrust side here, we just put a slight little chamfer on each thrust edge. That's just so that if there's a slight misalignment of the thrust bearing, we're not going to have something shearing oil off of the crankshaft. That's the whole purpose of that. Okay, so now what we're going to do, we're going to put these bearings into the case. We use a lint-free cloth. I like these blue shop towels for this. I always wipe this down with lacquer thinner. As you know what they say with engine building, cleanliness is next to impossible. So we wipe this all down with lacquer thinner. And by the way, when you clean your block, it should be clean enough that you can go ahead and, you know, run lacquer thinner rag in anywhere you want and come out, and there shouldn't be any dirt on it. Lifter bores, lifter bores have all been scrubbed and washed out with lacquer thinner. I run brushes through all the oil galleries. Cleanliness, just, you know, the most important aspect next to sizing. But yeah, we'll wipe off the bearings, front and back side, make sure they're nice and clean. This is all good and clean. Also very important too, now after we check our clearance, when we take this back apart, that we make sure each bearing shell goes back into the same position, because these bearings, like I said, have been coated, so that will affect the clearance slightly. But even if the bearings hadn't been coated, bearings aren't, if you check bearings with a ball mic, they're not always quite as consistent as you'd like, and there can easily be a couple tenths difference between them. So I just like to keep everything all together. So we'll do this, do the same thing with the other case half, and then we'll start check and see what our clearances are. Okay, I just mic'd up the crank. Just FYI, whenever I mic up a crank, I'll do it in at least 4 spots. I'll do it here, then up here. You got to be careful to stay away from the radius here, so I'm checking for taper, and then go 90 degrees. This crank was done by, just a fantastic place. This is no $125 crank regrind. This was a $500 crank regrind. There were 2 journals where he missed my target. He didn't actually miss. It's just these were standard, and I just needed between a half a thousandth and 1,000th taken off the mains. The crank was rehardened, has to be straightened and polished and what have you, and one journal had to come 3/10 under, another journal had to come 2/10 under my target. That's just because that's what physically had to be done to make the crank straight and everything else. So, I mean, that's just as perfect as you can get. You just can't get better than that, which is part of the reason why it pays not to go out and get a $125 crankshaft when, it's really like a $500 one is what you need. Somebody else may be able to do a crank as well as this, but nobody can do it better. And there's something else I want to really point out to you on this. You can see polishing marks in this. There's no way around that. Anytime you have a crankshaft polished, you will see they're basically using a very fine sandpaper. You'll see polishing marks. The thing to notice is that these marks are exactly straight across. There's no angle, no crosshatch. I've seen guys that, like on a Corvair crank, it's hard to do because the journals are so damn narrow. But like on a 350 Chevy or something, to where when they're doing the rods, since the belt is not wide enough to cover the whole rod throw, they'll go back and forth like this, just back and forth across the throw like that, creating kind of a crosshatch. And there's a real problem with that. First off, while you may have 2.5 thousandths oil clearance, bearing clearance, you only have between 20 and 50 millionths of an inch of oil preventing metal-to-metal contact. The crankshaft does not ride in the center of the bearings. The crankshaft is riding off to the side, and in a boxer motor like this, it's going to flop side to side, back and forth. You only have those 20 to 50 millionths of an inch of oil, just that little thin film. Now, if you have polishing marks that are going like this, that's helping scoot some of that oil away from the bearings. By having them straight, it actually helps retain oil. So that's very important. That's one of the things you look for on a proper crankshaft finish, and that's one way you can tell if somebody knows what they're doing or not. Is if they got those marks going back and forth every which way, like so many guys do, I mean, that thing's just junk. This is a forged steel crank, so the direction of polish is not that important, but still, it's a good idea to have the crankshaft, to have the belt running in the opposite of crankshaft direction. On a cast crank, it's critically important because you have ferrites and kind of like fish scales almost. They're microscopic, but if you polish in the wrong direction, you stand them up, and then as the motor's running, these things will cut into the bearings. And I do know of motors that have gone through like multiple sets of bearings and everything looked fine, and what it was the crankshaft was polished in the direction of rotate. The belt was traveling in the direction of rotation instead of against it.